Hello everyone. Today's first topic is dissimilarities between Coulomb force and gravitational force. Okay. So first, dissimilarities between Coulomb force and gravitational force. So first dissimilarities is Coulomb's force is attractive as well as repulsive. Okay, but gravitational force is always attractive. So this is the first dissimilarities. Second one is Coulomb's force is much stronger than the gravitational force. And the third one is Coulomb's force depends on the medium between the two charges always while there is no such dependence in case of gravitational force. Okay, the first dissimilarities is Coulomb's force is attractive as well as repulsive, but gravitational force always attractive. Okay, and the second one is Coulomb force is much stronger than the gravitational force. And the third one is Coulomb force depends on the medium between the two charges, right? Between the two charges, because Coulomb's law depends on permittivity, and permittivity depends on nature of the medium. So that's why we can say Coulomb's force depends on nature of the medium where we placed two charges. But gravitational force does not depend on medium. Clear? So gravitational force does not depend on medium. Okay, so now second topic, vector form of Coulomb's law. Coulomb's law in vector form. Okay. Now we take up x-axis, this one is y-axis, and it's a origin O, and this one is z-axis. Now we take two charges Q1 and Q2. So let us consider the position vector of Q1 charge with respect to origin is R1 vector. Okay. So R1 is the position vector of Q1 charge with respect to O point or with respect to origin. Now I am considering position vector of Q2 charge with respect to O point is, or with respect to origin is, suppose R2. Okay. And now the position vector listen very carefully. Position vector of Q2 charge with respect to Q1 charge. Position vector of Q2 charge with respect to Q1 charge represented by R21 sign. Okay. And the direction is Q1 to Q2. Clear? So this is the direction of R21. What is R21? R21, again I am repeating, R21 is the position vector of Q2 charge with respect to Q1 charge. So, here from triangular law of vector addition, we can write R1 vector plus R21 vector equals to R2 vector, right? These two vectors are in same order and this one is in opposite order. So this is the resultant vector of this two vectors. Okay. So from this equation we get R2 vector minus R1 vector equals to R21 vector. If R21 cap is represent unit vector of R21 vector, R21 cap represent unit vector of R21 vector, then we can write R21 cap equals to R21 vector by mod of R21 vector. Clear? So if force, let us consider force exerted on Q2 charge due to Q1 charge is, let us consider force exerted on Q2 charge due to Q1 charge is F21. F21 represent force exerted on Q2 charge due to Q1 charge. So what is the direction of F21? If these two charges are similar charges, then we know the direction of, that means the nature of F21 is repulsive, right? So this one is the repulsive force because Q1 and Q2 both are in positive charge or negative charge. If both are in same charge, like charges, then the direction of F21 along this side. So this is the direction of F21. So now F21, from Coulomb's law we can write F21 equals to K into Q1 Q2 by Q1 Q2 by R21 square R21 cap. Here you can see these two vectors, that means force vector and position vector, both are in same direction. Okay, that's why no negative sign arises here. Now again I draw this picture, and now I am finding force on Q1 charge. Okay, so X, Y, and this one is Z, and this one is Q1 charge, and this one is Q2 charge. It's R1 vector, and this one is R2 vector. Now I am going to find force on Q1 charge. This one is the force exerted on Q2 charge. Now I am going to find force exerted on Q1 charge. So now I am taking position vector of Q1 charge with respect to Q2 charge. So obviously the direction is along this side, and this position vector represent by R21 vector. This is represent position vector of Q1 charge with respect to Q2 charge, right? So again, apply triangular law of vector addition. We can write R2 vector plus from triangular law of vector addition. R2 vector plus R12 vector equals to R1 vector. So R12 vector equals to R1 vector minus R2 vector, right? And so we get R12 vector equals to R1 vector minus R2 vector, and R12 cap, if R12 cap is represent unit vector along R12 vector, if R12 cap is represent unit vector of R12 vector, then we can write R12 cap equals to R12 vector by mod of R12 vector. Here you can see these two positions vectors are in opposite direction. These two position vectors are in opposite direction, and we can write, that means we get R21 vector equals to R21 vector equals to R2 minus R1, right? R2 vector minus R1 vector, and R12 vector equals to R1 vector minus R2 vector. So here you can see, if we take minus sign, then we get R12 equals to R2 vector minus R1 vector, and this is the value of R21. So minus R21. So here you can see R12 vector and R21 vector are opposite vector. Both are opposite vectors. Okay. So now let us consider a force exerted on Q1 charge due to Q2 charge is F12 vector. Then we can write from Coulomb's law, F21 vector equals to K into Q1 Q2 by R12 square R12 cap. So what is the direction of F12 vector? F12 is also attractive in nature. So this is the direction of F12 vector. So you can see if position vector and position vector R12 and also force on Q1 charge, both are in same direction. So no negative sign arises here. So this is the form of force which is exerted on Q1 charge due to Q2 charge. So if some important points, first one, when Q1 Q2, that means product of two charges, if product of two charges greater than 0, this is so if they are positive or both, if they are positive or both negative, or both negative. If both charges are like charges, then always the product of two charges is greater than 0. But when Q1 into Q2 less than 0, that means the product of two charges less than 0, if Q1 and Q2 are in opposite sign. So for sign convention, so from sign convention, if F12 vector equals to K Q1 Q2 by R12 square R12 cap, and F21 vector equals to K into Q1 Q2 by R21 square R21 cap. This one is equation 1 and it's equation 2. So from equation 1 and 2 are true for any sign of Q1 and Q2. So equation 1 and 2 are true for any sign of Q1 and Q2. If Q1 and Q2 have same sign, then Q1 into Q2 is positive, and also if 1, 2 vector is along R12 cap and if 2, 1 vector is along R21 cap. So forces are repulsive in nature. So if Q1 and Q2 have same sign, then Q1 product of Q1 and Q2 is positive. In this situation, if 1, 2 vector is along R12 cap and if 2, 1 vector is along R21 cap, that means both forces are repulsive in nature. So both forces are repulsive in nature. If Q1 and Q2 have the opposite sign, if Q1 and Q2 are in opposite sign, then product of Q1 and Q2 is negative. And then if 1, 2 vector and R12 cap are in opposite direction, and also if 2, 1 vector and if 2, 1 cap are in opposite direction. So in this situation you can see if 1, 2 vector and if 2, 1 vector both are in attractive in nature. So in this situation, if the Q1 and Q2 are unlike charges, then if 1, 2 vector or if 1, 2 force and if 2, 1 both are attractive in nature. So what is the formula of if 1, 2 vector? Then if 1, 2 vector equals to K Q1, suppose Q2 is negative charge. So Q1 into minus Q2 by R12 square into minus R12 cap. If 1, 2 and R12 in opposite direction, that's why this negative sign. arises here. So now we get K Q1 Q2 by R12 square R12 cap. And if 2 1 vector equals to K Q1 minus Q2 by R21 square minus R21 cap. So K Q1 Q2 by R21 square R21 cap. Okay, so this is the formula of if 1 2 and if 1 2 and if 2 1 vector. So if 1 2 vector equals to K into Q1 Q2 by R12 square R12 cap. So we already know the magnitude of R12 vector is equals to the magnitude of R21 vector. So we can write Q1 Q2, we can replace this R12 by R21. And we know R12 cap equals to minus R21 cap. So here you can write R12 cap equals to minus R21 cap. So now we get K Q1 Q2 by 21 square R21 square by R21 cap. This is the formula of if 2 1. So if 1 2 and if 2 1 are always in opposite direction. So if 1 2 vector equals to minus if 2 1 vector. So from this equation we can say Coulomb's law obeys Newton's third law of motion, or in other words Coulomb's force is Newtonian in nature. We can write Coulomb's force is Newtonian in nature. Because according to Newton's third law, action and reaction always in opposite direction.